The fundamental theorem of algebra states that if a polynomial of a degree of n, and we want n to be greater than 1, then the polynomial has exactly n roots, including multiples and complex roots. An example, we know that y equals x squared is a quadratic equation, and we always say that it has a maximum of 2 roots. 2 real roots. So, and we get that because of this, that your exponent is a 2, its degree of 2, and that's why we have a maximum of 2 roots, or 2 real roots, and then of course we know that we have 2 roots based on the fundamental theorem of algebra. They just may be multiple or complex roots. So if we look over here at our first example, it says using the fundamental theorem of algebra, what are all the roots to the equation x to the fourth plus 2x to the third equals 13x squared minus 10x? Before we do anything, we can put it in standard form, of course, but we should be able to look at this and say the degree of this polynomial has got to be a degree of 4. And so it tells us then that we are going to have 4 roots. We don't know if they're going to be real or complex, real or imaginary, but we have 4 roots to this polynomial. And even looking at this next example, we haven't even done it yet, but we should be able to look at this example right here and say it also has 4 roots because the degree of the polynomial is 4. So looking at this, we'll do some inverse operations. Okay, so now that we've done our inverse operations and we have it in standard form, we can again see that our degree is still 4. When we combine like terms, nothing was eliminated. And looking at this, anytime we're factoring, we want to make sure that the first thing we do after we put it into standard form is that we look for greatest common factors. And you should be able to see here that all our terms have a greatest common factor of x. So we can go ahead and factor out x, and leaving behind, if I divide each one of those terms by x, I have x to the third plus 2x squared minus 13x plus 10. Okay, so I already know one of my roots is going to be x equals 0, and we have to look for our next root. And in order to look for those remaining roots, I could go ahead and figure out all my possible rational roots. And what we learned before is that I would take my possible rational roots from the factors of the constant over the factors of the leading coefficient. And we know that the constant is going to be 10, and the leading coefficient is going to be 1. Here we go. And so the factors of 10 are going to be plus or minus, plus or minus, plus or minus, plus or minus 10 over plus or minus 1. So the possible rational roots here are going to be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. So if I'm going to go ahead and use synthetic division to try and figure out one of these next possible roots. So if I take x to the third plus 2x squared minus 13x plus 10 equals 0, and I'm going to go ahead and use synthetic division, and I'm going to start off with 1. And doing synthetic division, I'm going to go ahead and I have used my coefficients to create my synthetic division, and as I add down, I get 1, I go ahead and multiply, I get 1 times 1 is 1, I add down again, I get 3, I go ahead and multiply 1 times 3, and I get 3, add down again, and I get negative 10, and 1 times negative 10 is going to be negative 10, and I end up with a remainder of 0. And we said, and we learned before, that if we have a remainder of 0, then yes, that is a root. So I have just found another root, which is x equals 1. And I have x equals 0. So there are two of my roots. Let's see what is left here. When I rewrite my equation, I have x squared plus 3x minus 10. And I'm going to need to use the quadratic formula here to solve this because there are no factors of negative 10 that will... No, never mind. There are factors of negative 10 that will give me 3. And I know that that should be x. Let's see here. We have negative 10 is going to be 2 times negative 5. That gives me a negative 3, and that's not what I want. I want negative 2 times 5, which gives me a positive 3. So these are going to be the factors that I'm going to use. There we go. And solving for 0, x minus 2 equals 0, x plus 5 equals 0. Doing my inverse operations. So we have just found 4 roots, x equals 0, x equals 1, x equals 2, and x equals negative 5. Using the quadratic formula, using synthetic division, using the greatest common factor. And of course, if we went back and looked at all of those roots end up falling under our possible rational roots. Okay, looking at this next example, finding all the zeros of a polynomial function, what we can do here is we know that, what are all the zeros of this function? G of x equals 2x to the 4th minus 3x cubed minus x minus 6. And if we take the factors of our constant over the leading coefficient, we get, let's see, pause. All right, and we get the factors of 6 are going to be plus or minus 1, 2, 3, and 6, and then the factors of 2 are going to be plus or minus 2. And so when I do my numerator denominator, I get 1, 2, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then when I get plus or minus 1/2, I already have plus or minus 1. Then I add plus or minus 3/2, and then I already have plus or minus 3 there. So here are all the possible rational roots. And let's see, what we're going to do here is I'm going to show you put this function right here, we're going to go ahead and put that into the graphing calculator to where it gives us somewhere to start. Okay, and what I want you to see here is I've gone ahead and I've plugged this function into the graphing calculator because, quite honestly, let's look at this. I have 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12 possible roots. Where do I start with my synthetic division? So by plugging this into the graphing calculator, I can see that I have what looks to be x equals 2 and x equals negative 1 are two possible roots. So I'm going to start synthetic division right there since I do not appear to have any greatest common factor. Okay, so again, for synthetic division, I needed to make sure that I did account for my x squared since there wasn't one in my polynomial. And remember, I'm going to add down with my coefficients, multiply across. So 2 times 2 is 4. 4 minus 3 is 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 4 minus 1 is 3. 3 times 2 is 6. And then that is going to be 0. So it looks like my remainder is 0. So yes, x equals 2 proves to be one of my roots. And let's see, if we rewrite this, we have 2x to the 3rd plus x cubed plus 2x squared plus 3x. And let's see. And I'm sitting here looking at this saying something's wrong. So let's fix this, fix that, fix that. So it is 2x cubed plus 2x, or plus x squared plus 2x plus 3. Okay, much better. Now we know then that we did have -1 was a possible root, so we can go ahead and do -1, and then bringing down my new coefficients are 2, 1, 2, and 3. Go ahead and do your synthetic division. 2 down is going to be 2. 2 times -1 is -2. -2 plus 1 is -1. -1 times -1 is going to be 1. 2 plus 1 is 3. 3 times -1 is -3. And again, there you go. I was able to prove that root is, when it's equal to 0, I have a root. Rewrite this. I have 2x squared minus x plus 3. And let's see here. What can we do now? I believe we are going to need to use the quadratic formula to factor this one. So we know that a is equal to 2, b is equal to -1, and c is equal to 3. I hope that you remember that x is equal to -b plus or minus b squared minus 4ac all over 2a is my quadratic formula, and what we want to do now is populate the a, b, and c into that formula and simplify. Alright, so I've gone and substituted in my values of a, b, and c into my quadratic formula, and we can see here that negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times -1, and when we simplify that, okay, so we were able to simplify that into 1 plus or minus the square root of 1 minus 24 over 4, and then simplify that internal square, or that square root, to 1 plus or minus the square root of -23 over 4, and then finally x equals 1 plus or minus I times the square root of 23 over 4. So here are two of my solutions. Here is a third solution, and this turned out to be a solution, so x equals -1. So there you go. The calculator can give you some information. It gave us two of our roots, but it was unable to give us those complex roots or imaginary roots. So therefore, we had to use the quadratic formula to find the missing roots.